Assalamualaikum and hi. Today I want to teach all of you how to manually solve LP problem using BM method.
When we need to use the BM method. Okay, we need to use the BM method when there is at least an artificial variable in the W form.
Given m is sufficiently large positive value, the objective coefficient of an artificial variable represents an appropriate penalty if artificial variable objective coefficient negative m in maximization problem and m in minimization problem.
Okay, in this question, A. We must solve the LP problem. B. Find the dual LP for each of the problem. And C. Find the dual solution for each of the LP based on their optimal W.
The LP problem is stated in the A. So, if we want to solve the LP problem, we must convert it to the standard form, like this. In constraint 1, we can see the equation is less or equal than 5. So, we must plus S1, so the equation can be equal to 5. In the constraint 2, we can see the equation is equal to 10. So, we must add A2. x1, x2, x3, s1 and a2 is more or equal than 0. After we convert the LP problem to standard form, we must convert it to the table form. So, it's easier to us to put the equation in the table. Then, we must make the table like the video shows. After that, we must put the equation in the table like this. As we can see in the table, only row 1 has basic variable. So, we must make the equation in row 2 to have a basic variable too. So, we must eliminate the artificial variables from row 0 before beginning the simplex by getting a new row 0. So, the formula to eliminate the artificial variable is row 0 minus m row 2. After that, we can get updated W. As we can see, the coefficient in row 0 is changing. Next, we must choose entering variable. Since this is maximization problem, so we must choose the most negative coefficient in row 0. So I choose negative 36 minus 6m. As we know, m is a large positive value. So if it negative m, it was a large negative value. So that's why I choose negative 36 minus 6m as a entering variable. So x1 is the entering variable. Then we must select a leaving variable by choose the smallest ratio like this. The formula to find ratio is right hand side of the equation is divided by the coefficient of entering variable. Example, 5 divided by 1 in row 1. So the ratio is 5. So the leaving variable is A2. So we must remember to choose the small. In a nutshell, we can get table 1. The number in table 1 is changing. The reason behind that is the formula that we use to make x1 become basic variable. If you want to see the formula, you can see an updated table in this video. Like before, we must choose the most negative coefficient in row 0 as entering variable. So I choose negative 2. x4 is the entering variable. Then we must choose the living variable. So the ratio for row 1 is 20 and there is no ratio for row 2. So the living variable is S1. We must make a formula for X4 to become basic variable. 1 is the value in the box of intersection line of entering and leaving, and other S4 column must be 0. So from that we can make the formula. Example, to make 1/6 become 1, we must multiply it by 6. So the formula for the row 2 is 6 row 2. Then we can get W2. We can use the same method to find the entering variable and leaving variable. As fast as lightning, we can see -9 is the most negative coefficient in row 0. X3 is the entering variable. As we can see, there was no ratio. We just only have entering variable but did not have leaving variable. Thus, this LP has unbounded feasible region. As S1, S2, S3, and S4 increase, Z will increase. B. Dual LP. The number of variables in the dual problem is equal to the number of constraints in the original primal problem. Coefficient of the adjective function in the dual problem comes from the right-hand side of the original problem. The problem is a max model, so the dual is a min model. The coefficient of the first constraint function for the dual problem are the coefficient of the first variable in the constraint for the original problem. The right-hand side of the dual constraints come from the objective function coefficient in the original problem. There are general rules for constructing the dual problem. If we follow the rules, we can easily do the dual LP like in the video. C. Since it is unbounded, there is no optimal solution, so it is unbounded solution. Assalamualaikum and hi. So now, I want to teach all of you how to solve LP problem using Excel solver. The LP problem is same just like before, but in this video, we gonna use apps. Okay, first, click File, Option, Add-ins, Solver Add-in, and then click OK. Write down the variables. It's up to you either to choose color or not, but we choose the pink color. Write down all the variables. In this case, we only have 4 variables. Then write 0 in all right box of variables. Write objective, then just choose your color. Just like I said before, I write pink, so I choose pink color. After that, write maximize equal to 36 times represented by star symbol. Then click the value of x1 plus 30 times value of x2 minus 3 times value of x3 minus 4 times value of x4. Then write down all the constraints. We already have 2 constraints, but we need to add another 4 constraints depends number of variables. So total constraints is 6. Write constraint, then choose your color and write 1, 2, 3, 4, 5, 6 under the constraint. After that, right inequality, and right hand side. Okay, constraint 1. We just write down the equation. 1 times x1 plus 1 times x2 minus 1 times x3. Less than or equal than 5. Okay, constraint 2. Just write down the equation. 6 times x1 plus 5 times x2 minus 1 times x4 equal to 10. Okay, constraint number 3. Just write down the equation. 1 times x1 more or equal than 0. Equation number 4. 1 times x2 more or equal than 0. Equation number 5. 1 times x3 more or equal than 0. And lastly, equation number 6. 1 times x4 more or equal than 0. After finish, click data, then solver, OK, reset all, and then OK. After that, click maximize button, click objective, and then click right box of maximize. For changing variable, choose all value of x, then click add. Click value for first constraint, then choose suitable symbol, then click value right hand side, then add. You must do all the method to other constraint. Click OK. Then for solving method, choose simplex LP. So the solver can make, it won't mean. We can conclude this problem have unbounded solution. Value of x change and value of x1 is 5, x2 is 0, x3 is 0, and x4 is 20, while z is 100. That's all from me. Thank you.